Hello coders, welcome to my video. So in this video, we will be studying about one of the most important IPC technique, that is the shared memory. It is one of the fastest IPC that we use in our programs for caching. Okay, so first, let's understand what is a shared memory. So, shared memory is an IPC mechanism where two or more processes map to the same memory region into the address space. So, what do you mean by that is, for example, I have process P1 and process P2. So, P1 creates the shared memory. So, how a process P2 access that memory? As there is a segregation or the security violation for the data that is created when one is shared or the address space is shared to the second process. We cannot directly share that address space between the processes. But in this mechanism, we overcome that restriction and we share the address space to another process. Okay, so both the processes will be pointing to the same physical memory where that data resides. Okay, for example, I'll give you a view. For example, I have a process P1. Okay, so I have a process P1 and that creates a memory M1. Okay, and P2 is also accessing this memory. Okay, so the virtual addresses that is mapped to this memory, and this memory have some physical address. Okay, so this virtual memory, maybe it is XYZ, maybe it is mapping to M1. The same physical memory is being mapped by the virtual address, for example, ABC in P2. So though the virtual addresses may be same for this process, but they are pointing to the same physical memory where your data is. Okay, so this is how the shared memory actually works. Okay, so why it is fast? So this is our next question. So there is no kernel buffer that is copy after this setup. For example, we have IPC techniques that copies the data from the user space to kernel space and then copy back from kernel space to user space using some APIs. For example, copy from user and copy to user. Okay, so that APIs are being used, and this will create the overhead, and that overhead is not there because here this M1 is simply a file in the tempfs. Okay, is just a file. Okay, and it resides in the RAM. So just like a cache, if you reboot the system, this memory will be gone. Okay, so there is no context switching and the overhead for the data transfer because P1 is writing to this memory, and as P2 is also pointing to this memory, it's easy for both the process to read and write. So, so the overhead for read and write is not there for this memory because both of the process pointing to the same memory. So whether P1 writes in this memory ABC, so we have data as ABC here. Okay. So for example, I write it and I have a pointer over here now after this C. So our P2 is also there, just pointing to A. So if P2 needs to read the data, it just starts from here and goes to C. Okay, so there is no overhead in this process, no context switching, no kernel buffer copy, and there is a direct memory access between the processes. Okay, so this is very basic regarding the shared memory. Okay, so here we will be studying about the POSIX APIs that helps in creating this memory and accessing this memory. Okay, so in this setup, what we will do, we will have a reader and a writer. Writers write the data in the shared memory, and the reader access that. That's it. Okay. So we will be using this list of six APIs. Okay. So starting from SHM open, it will create an object of shared memory. Okay, simply. So it will return a file descriptor on which we'll write. Okay. F truncate will set the size of that buffer. Okay. Then mmap will map to that memory. The process will map to that memory, and this will unmap memory. Okay. So we are talking about shared memory region here, memory, this memory. Okay. So next is the shared memory unlink. We'll unlink from this memory and we'll close that file descriptor that we create here. Okay. So let's start with the coding. Okay. So what I will do, I will start with the first API, and that is shm open. So it will create the shared memory. Okay. So I will put like this, create the shared memory. Okay. So what all are the parameters? So I need the name of the file that will be created as a shared memory. So it is shm name. For example, I named a macro. Okay. So here I will take hash define shm name, and I'll take the name as slash my post 6 shm. Okay, so this is the name of my shared memory file that will be created after this operation. Okay, so next parameter is we need to create it, so we need o create. Okay, and we need to make it as o underscore read write, and last is our permissions. Okay, so once we create this shm, then it will return an fd. The file descriptor will return for that file. Okay, so if fd is equal to -1, then there is an error. Okay, so for that, I will throw an error here, and that will be b error on such a m open. Okay, and here I exit one. Okay, so I have created my shared memory till here. Okay, and second thing is we need to set the size of that file or the memory. So for that, second, what I will do here, I will put the second API, and that is f truncate, which is SD and size. And size I will take as defines size, and it would be, for example, 1K. Okay, so this step will set the size. Set the size. Okay. So once we set the size, the third thing is we have to map the memory. So we will need to map the memory, and for that we'll use an API mmap. Okay. And for that I need first is null. Okay. Second is the size. Okay. The size is the same that we have created here. So 1024. Okay. Third thing is we have to make it for read and write. Okay. And next is a very important thing that we have to do map shared. And next is a FD and last is a zero. Okay. And once we map it, we need a pointer for that. So I'll take a pointer. Next thing is we need to write the data into that memory. Okay. So we just check if pointer is equal to map field, then we have error over there. So I will put mmap error or something. Okay. And I'll exit from here. So these pointers are very important. If we won't get this pointer, our program will fail. Okay. So once we clear this nmap thing, now the next part is what we have to write the data. So I will write the data. Okay. For that, what I will do, I will take string copy. Okay. And here, what I will do, I'll just have the pointer. I have hello from the writer. Okay. Just a string. I just put it into this memory. Okay. And next is just for reference, I will write data return to shared memory. Okay. After that, what I will do, I'll have a sleep. I just wait for 10 seconds so that the reader can read this data. Okay. And next thing is I need to unmap it. Unmap this memory. Okay. So MUNMAP is there. Unmap the memory. Okay. For that unmap this pointer and size. Okay. So I just unmap it. Now the next is I just need to close it. So I'll close this FD because my work is done. Let's close this. Okay. So what I have did there, I create a shared memory. Okay. So if this is the first point, then second is we set the size. Third is we map the memory. And fourth is we write the data. I unmap the memory and last is close the descriptor. Okay. So after this operation, I'm able to write the data. Okay. So this my POSIX SHM, this file will be there in the file system. So let's see first whether that file is created or not. So I just try to compile this. Okay. And I think we missed the header files. So hash include, I have sys mn.h. Okay, and hash include, I'll take uni std dot. Okay, so I've just taken this and now I need to compile this file. So how I will compile? I'll take the writer hyphen o and I have writer. Okay, so I got this error. Okay, so if I check the man page of SHM open, so I need these all files. So I think this and this is missing. So I'll copy this and I'll just paste it over. Okay, now if I compile it again, I got an error undefined reference to SHF open. So I need a library to compile it, and that is RT library. So if I do this, I got the writer. Okay. So now if I write, okay, so I wait for 10 seconds and we'll see whether that file has been created or not. Okay. So now data returned to shared memory is showing here. Okay. So, so I'll do cat slash dev shm, and here is my POSIX shm. So this is the file that is created. So it's not a link, it's a file only. Okay. So if I do cat on this, I got hello from writer. Okay. Again, if I do cat, I also get this and this. Okay. So this queue is not been empty because we are not reading it in a proper way from a process and unlinking this memory. So writer only writes that file. So now he's waiting for the reader. So in order to create the reader, what I will do, I'll take the writer.c and make it writer.c from here. Okay. So I have reader.c because most of the APIs will remain same. So that's why I'm doing this. Okay. So first open that we need. Okay. Because we need to use this. We don't need to create it. So I only need to read in this case. Okay. So I'll take RD only. Okay. So everything remains the same. This set the size. We don't need to set in read. So I delete this. Second is map that I need because I need to map to the same memory that is created by the writer. Okay. And for that, I think number is fine. This for write, I don't need. I only need read and map share FD0. So this is fine. So in spite of writing over here, I just need to read. Okay. So I will take read the data. So this is the third point. I'll just read the data and I need to reader received colon percentages and we have PTR here. Sleep we don't need. Okay. Then we have to unlink. This is fine. And we have to close that. Okay, simple as that. So I compile it the same way. I compile for write. So here we have reader, and for reader.c. Okay, so now I got reader and writer both. So first what I will do, I'll just have writer. Okay. Okay, now data is written. So if I again cat and check whether data is there or not, yes, it's there. Again, it's there. But now I place my reader and try to read it. So you see, reader receive this hello writer. If I do this, I got this data again. If I do reader as well, I got this data. So why this is happening? Because I have not removed the shared memory after reading. Okay. So I missed one statement. After I close the FT, after all my work is done, I have to do SHM unlink. And what I have to unlink? SHM name. Okay. So once I do this, I destroyed the shared memory. Okay. I again compile that reader. Again, I do a writer. I run it in background. Okay. So this created, and now I read it. And again, if I read it, there is no file there. So I removed that shared memory. So this is the proper way how to access that shared memory as a file. So this is very basic of the shared memory. So let's see in the next video. Thanks.